you talking about running it through town, or you just are?
Well, Ted's saying you already have an 8-inch pipe.
Right. Yes.
Why not use that as your transmission main? So don't run through the PRV.
Right.
Keep the pressure high so you can feed the other side. Put PRVs along the connecting pipes.
But wouldn't you have to have bypasses for those PRVs? You'd have to take the transmission line past the PRV. Wouldn't you be having bypasses for everybody else that's on the PRV?
Yeah, it gets so you could do that. You could bypass it because
you want to be pumping through PRVs. I wouldn't think.
Well, then your PRVs are big because you'd have an 8-inch PRV and then you'd have a 2-inch PRV for normal flow.
Right.
Because a big PRV is going to.
But I mean, if you're having PRVs going on downtown, how are you going to get that water pressure back up above?
With the PRVs would be not on the main line, but on the sidelines.
Right.
So you'd have 10 PRVs going out to the 6-inch.
So your branches off of the main line.
Yeah.
Okay. And then with it being, that's where everybody would get serviced off those PRVs, correct?
Correct.
That sounds pretty complicated.
It gets complicated. And the other thing is if you have anybody that's on that 8-inch line, so directly off the 8-inch line, which you probably do, or you don't?
I don't think so. Maybe the base.
Let's take a look. I'm looking right here right now. Let's see. I mean,
what's the price roughly on a PRV then?
I would think the RV serviced off the 8-inch.
We usually budget $30,000 to $50,000 for them. For a new PRV, because you
dig and install and
dig install all the parts and
So
pieces.
that could be
$400,000 just for PRVs. That makes the 12-inch pipe look a lot good.
well,
It does.
it's still $1 million.
Well, it still is, but to me, it has future
It has
use.
some value.
Still $1 million
This
plus
doesn't.
running a line over to the other.
Well,
area. That's anywhere from
the one thing
$600,000
you're forgetting is that with that 12-inch line, you have a heck of a lot of capacity in that 12-inch line.
Right, that's where we're getting the way.
And that's how we get rid of this drill more tank. You've got significantly more amount of water in a 12-inch than a 6-inch.
Yeah,
You'll have more water.
And we
You'll
have
have
to deal
more
with
pressure.
drawing water.
Yeah, so I mean, turning it done, that $40,000 can turn to $1 million really fast.
But I definitely think that
They said it's half.
this ought to be on the same pressure zone as everything else on the top.
It would, and so you definitely have to reconnect that PRV there, and that goes on.
Yeah.
Well, and besides that, those 2-inch pipes feeding that whole area.
Yeah.
If it were for my money, I'd get rid of Dromore. I'd run this pipe around here, and just forget about that old Dromore system because it was.
I mean, it's ridiculous.
Well,
And even if we had to put in a pumping station there, it'd be a lot cheaper.
We don't want any pumps.
we're
If we
talking
can avoid it, it's always better.
1970. So, here we go.
So does that make sense? Kind of what we're talking about for pipes. So this down here in the Farragut area is to replace the old what we think might be leaky lead joint pipes. This pipe that goes around the perimeter here really is to take that water, take it up to the upper part to provide higher pressure up here
and fire flow.
and fire flow. And then the same thing with this pipe there. There are lots of different ways you can route things. You might be able to avoid some of this pipe here and just use that upper pipe. There are lots of things, lots of ways you can configure it. Ultimately, if you end up putting a tank up here, it benefits you there. But that's a future decision for district. For my money, I would get rid of any old pumps and tanks you can. They just don't. They don't have much value. They're maintenance headaches.
Gravity's cheaper.
When the fleet says up the PRVs and then the tank and the booster station there, you're getting rid of a lot of
headaches.
I think so. It makes your system just a lot more robust. The other nice thing about having this line that goes around there is when you have a problem on that down here, because you will, you've got another way to feed most of the system. Right now, you only have, what do you have, maybe 15 valves in the system?
Yeah, there's only 2 ways in. The main way into town was that 8-inch, and you got the little branch off to the west to feed the area around 1st and 2nd Street, 1st, 2nd, 3rd Street, that area.
So if you have a problem down here, basically everybody from there, north and east, is out of water. So it gives you that flexibility.
And Steve, if you did that with the 8-inch pipe, like we were just talking about, you said
This
you
one
would.
down here?
Yes, you would lose the looping. So does that mean the people on the west end that are having a pressure problem would have a pressure problem because of the lack of looping?
Well, not exactly, because I think your pressure would come up. You'd maintain pressure over here, but what it means is it'd be a lot harder to get your fire flows down there
Okay.
because you can't connect. So what we want is, if I need fire here, it's nice to have multiple pipes for the water to come through.
Right.
With PRVs, it's hard to adjust them so you're getting the same amount of flow from each one.
How do you feel about that, Ted?
Well, and also without the looping, if you don't get enough water flowing through, then your water gets stagnant in the line.
It gets, and so I think your idea has some merit. I don't think that if we didn't have to meet the pressure and fire flow up here, it would make a lot of sense. And there may still be value to it.
But I think that would meet the fire flow. I mean, I would like to see an engineer study on it and see if it would.
And I think if that's, when you guys, let's say you pass the bond, you move on, that would be something you could take a look at. What would it take? All that's modeled. It doesn't take much to do that.
Right.
So that's the pipes. Any questions on any of that?
Well,
Any
like
more
you say, you
questions?
stay with that 8-inch, you still gotta deal with the Dremore and the booster station there.
You might be able to replace some of this. If that 8-inch comes through and you have pressure, you might be able to eliminate it, but that's what you want to model. I think with that 12-inch, it just barely makes it. And so I don't think that 8-inch will work, but again, I haven't looked at that specifically.
If we did upsize that piping, would it require an engineer to look at it? Because it would be a system upgrade, and then it would need to go in front of DEQ as well?
Yeah.
Correct? Okay.
Anytime you do a changing a pipe size, it's supposed to be engineered in the state of Idaho.
Mhm.
And there's some simple ways to do that, but
Yeah, it
It would.
would. I'm not disputing that.
yeah.
You don't want to cut
Yeah, I was just
engineer.
Let's go dig it up and put a new line in.
Well,
Ted and I'll get the shovels out.
Ooh, that's hard digging up there.
Yeah, it
Good
is.
luck with that one.
Yeah.
And this report here, I was told that to connect to the new storage tank, I was told that was a typographical error, but I think it was a Freudian slip.
Which one is that?
That was on the,
Ted, I have no skin in the game here. I'm here to do what you want. If it's Freudian slip, we need to fix that.
Yeah, it was down,
that was on the spreadsheet with the different,
down here, it says to the new storage tank, and it should be from north, or from south of Bayview to north of Bayview.
Oh, yeah, and that was originally to connect, okay.
it was a copy and paste error is what it
Well,
is.
I'll explain why that was that way.
Yeah.
It is I should have edited it, but it was originally to extend up to the tank. So we should get rid of it. So it includes that little leg there, which you wouldn't necessarily have to do. So it wasn't that it was copy and paste. It was that it was easier to keep one pipe that would either do the new tank or not do the new tank. So there's some flexibility there. But yes, let's cross that sucker out. Let's pretend it's not like that. Yeah, I have a few scars from that tank. So if we look at tanks themselves, we've got a couple options. We've got the rehabbing the existing tank. We talked a little bit about that. A new tank up here, Drumore tank, and then of course you have the tanks that are behind the other stuff over there. So there are other tanks up on Cape Horn. Of these, I would love to get rid of Drumore. If you guys rehab that one, it doesn't quite meet all your fire flow requirements, but by putting a backup power on well number 8, you can meet all the requirements. So there are ways to make that work.
Well, with the 12-inch line coming off of that tank, wouldn't because you've got 750 gallon per minute pumps feeding the tank.
Yeah.
Wouldn't that really, provide you enough capacity and flow?
Well, so what DEQ requires is a fire flow that's 180,000 gallons here. When you add up all the other requirements you have, the emergency storage plus the just the operating storage,
Peak demand.
the peak operating storage is peak demand. You don't have enough storage in that tank, and so what you need to do is eliminate the emergency storage requirement.
But you would have storage in that 12-inch pipe, though.
12-inch main would have.
Oh, I see what you're saying.
Yeah.
This storage back here.
Yeah, that 12-inch, that 12, well, you probably haven't done the
I have not done
calculation
that
on that,
calculation.
but it would be quite a bit.
It would. I don't think you. I've never had anybody count that. I don't think you can count it because this 180,000 gallons still has to replace that water in the pipe. I don't think you can count it, but I don't know that.
Well, that, yeah,
I've never had anybody ask that question.
yeah.
And for, I know for a factor that we needed that much water. I know all we'd have to do is, if we wanted to pay to have the park tank full all year round,
You could get some of that.
all you'd have to do is turn the valve.
But what is that connection size, Bob?
That's higher than ours.
It's
It
higher.
is.
I think it's a pretty small
Yeah, it's
connection.
either 6 or an 8.
Well, if it's an 8, you might be able to get close.
Yeah.
The thing about it, Ted, is it has to be automatic. So if you had that, you'd have to keep the tank full, and you'd have to have a valve that automatically.
You'd have to have your SCADA and you have
Yeah, and you could do that, right?
yeah,
Well,
you
but,
could do
but,
that.
but again, I mean, and that's in extraordinary circumstances.
It is. And that's part of what we do is we plan for that circumstance, right? What is,
But you're not gonna, no domestic drinking water facility is capable of handling forest fire.
no, well, this isn't a forest fire. This is just what we're trying to handle is 180,000 gallons for a commercial building burning downtown. So that's at 1,500 gallons a minute for 2 hours.
Yeah, and we've got that for most of the commercial buildings, the big buildings.
You do, but in order to meet the accused rules, you have to put that emergency generator. So you have to be able to meet your requirement with your largest source out of service. So that essentially you'd have to meet it with well number 7 out of service in the tank. And the only way to do that's that number 8 with the
And
generator.
the biggest one is right on the lake.
Right. And which you can fight from the lake. Yeah, I agree.
And wasn't there something said about the generator on well 7 a while back? We didn't need it?
Yeah, no.
Well,
Generator on well
because
seven.
we have a generator
But
on
it's
well
not
7,
automatic.
it just doesn't have an automatic
It's
generator.
kind of strong, man.
So you just need to
So you'd have to go up there and switch it
Well,
on when,
I know how
when
to.
the power goes out.
Well,
But well 7 does need an automatic switch, and that's not that big a deal.
no, that's not a big deal. And
No.
well, and so, or you could have somebody to sleep on.
Right, and we just, one of our upgrades with the SCADA
I'm not
system,
doing
we,
No way.
we increased the channel width. So I think that could be something in the future, right, Bob?
That's why I
And
said,
we increased our number of channels too on our SCADA system.
Oh, yeah, good.
that's what we're getting in here. We've increased our channels because we need more than one for Dromore. We've added more than that, so we used to get more channels.
Right.
Yeah, and then if we get rid of Drillmore, then
Get
we'll
some
free
channels
those
back.
up.
We can always put that on.
I mean, in theory, with our SCADA system, you could eventually hook up our sewer. That's why, by having more channels.
This was,
Automatic
this way
switch.
picked up channels too, yeah, it's a good
You
future
know,
uses.
the well 8,
Especially if you eliminate Dromore.
the well 8 generator is the one you said we don't need.
Well, it's kind
No,
of,
we're talking about putting automatic on
Yeah.
well 7.
well,
No,
what,
I'd like
the
to talk
generator
about
for
the
well 8, it's a nice to have. I mean, if we're running it consistently, I've talked to Bob, we want to kind of lead lag those wells so that we're running one at a time and then switch over. So, when we're running the one well, if we lose power, then you need that generator. But I don't know if there's something in SCADA that if we lose power to the one, that we have automatically go back to the
It
other.
automatically goes to well 7. Power drops, it automatically goes back to well 7.
Yeah, so maybe we don't need the generator at 8. I mean, it's,
Well, you do, if you're gonna use the existing tank to meet all DEQ's requirements, you do need a generator.
That's what I
We have
heard you
so,
say.
that's a DEQ
It's,
requirement.
it is, that's a
Okay.
redundancy requirement.
All right.
With that redundancy requirement, I know that we have the generator at well 8, the automatic startup, would that be a requirement?
That's seven.
That's
seven.
Seven.
Oh, okay.
So they,
Yeah, we don't have it
you
anymore.
need the automatic transfer switch at both.
So then, yeah. in
Yeah.
order to have
I don't know if you feel.
But that switch gear, I don't think is all that expensive for those.
No, 8.
startup.
I don't think
This
this,
DQ one sits.
I don't think that
That's
switch
not
gear
me. I don't
is
know.
all that expensive for those things.
So I heard it wasn't required.
On the generator on Wally.
Yeah,
Yeah, somewhere I heard it wasn't
yeah,
required.
and that was
Well,
one
they-
of your handouts.
I think Calvin was required if you decided to put a new tank up here. You'd have enough storage that wouldn't require that as a part of emergency services CBD.
But like, as he said though, I think the 12-inch line though will have it.
Well, that's what has to be figured out.
Well, that's, that was a question nobody's asked, if that could be used as part of
How
that
you
capacity.
use that, because remember, you need to have the storage up high enough that you get a pressure,
For
so
gravity
this
flow.
water down here doesn't do you any good.
Yeah.
So,
Well, yeah, unless we tie it in to the system down there anyway, it wouldn't do downtown any good. Because
Right.
that basically is to help the flow up here.
well, this is still connected to this lower, so that water here can still flow either
It's
direction.
all about gravity.
All about, yeah.
Okay, let's move on.
Yeah, good. So, and if you did a new tank up here, the benefit of that is you end up putting it higher. So all these areas down here that are just marginal by feeding off that tank, that gets better. So the way that kind of where this is headed, if you do end up putting this big pipe around here, you're set up for that. If you don't, you're still getting benefit from that.
Yeah. But, you just pointed to that area down there, that there is no problem. You said marginal, but there is no problem below the drill line.
It's not great. We're just barely over the line for DEQ. So you have to maintain at least 40 psi.
Well, at the lime kill, we have 65 pounds of pressure.
Right, yeah. And that's a lot better spot.
Yeah,
And
and
there is folks a block away.
that's kind of that area that you kind of pointed to.
But you're
Oh, I'm
folks a
sorry.
block away.
I'm saying
Yeah.
really
Yeah,
up top.
okay.
Sorry, I
Yeah,
was-
they barely have, 45 is what you said?
Up at Drumore?
Yeah, where my parents' place is.
45, yeah, put a gauge on there.
Okay.
Good.
You must have did it on a good day.
Yeah.
And then we'll talk just quickly about supply. That's pretty easy. You've got 2 fantastic wells. They're old, but wells don't.
They don't wear out?
They don't really get old. So your pumps and all that stuff is older.
I mean, we're getting it before anybody downtown.
Listen, and I'll tell you, we are so lucky to be on the ferry on the aquifer here. You guys are right on the edge, but you're in it, and it's fantastic. People in the rest of the country would die for this water.
Yeah.
Did we ever run cameras down to the bottom of the wells to see how the casing is and all the
Not since
springs
I've
are?
been here, I don't know.
There's some video footage of something. I think when
It's
they
the
pull,
tank,
That's the tank. It's in there.
not the wells.
Yeah.
not
Okay.
wells.
I don't think they've been checked. And it's these are old perforated casings. They don't have a screen in there.
Oh,
So this is the way they used to do it way back when. So in a lot of wells, you'll put a kind of a wedge wire, a mesh screen in the well. In other wells, they put they put a metal casing down and they run a big tool down that's got these punches that hydraulically come out and make holes inside the casing. So it'll typically make, actually they're more like slots. They're about maybe an inch by about 5/8 of an inch. And that's where the water comes in. If there were much sand there, it wouldn't work because the sand would come pouring in. Most of what you're in is pretty colorless material. It's gravels and big rocks, things that make it pretty great.
I was kind of wondering, how the silting is. I mean, if these are 1940 wells, it's probably not like anybody pumped them out and cleaned them out. So I was kind of wondering how the silt was in them.
And I don't know, typically on the aquifer, we don't get much silt.
Okay.
We get some sand that goes on the bottom,
And,
but wells this old, if you haven't had an issue, you probably don't have an issue.
okay.
We looked at, one of the things that one of the previous board asked us to do is look at putting wells here. If you couldn't negotiate a lease with with the Navy and the park, then could you drill them out here? And we think you're still right on the edge of the aquifer, so you might be able to drill something here. But honestly, you're going to spend $1 million to drill those wells and put pumps in, and you've got fantastic wells there. So I would like to see if you can work something out. Even though you have to pay for these pipelines, those wells are pretty amazing. Any thoughts about that, Bob?
No, I wasn't really aware of what they were talking about up here. Of course, you got setbacks, but yeah, the wells are in excellent shape. I mean, look at our water quality. We have more waivers we can possibly
Pretty
get
great.
for it.
And here you might start to get a little bit more of the bedrock. That's where you start to get a little bit of, sometimes you get some iron, sometimes you get some silt things and that stuff. So you've got a known down here.
If it ain't broke, don't fix it.
If it ain't broke, don't fix it until it breaks. Good. So that's that piece. I'm going to put this back. So there are a couple things that we've talked about this a little bit. I'll just skip through this really quickly. You want to balance critical system